My name is Sean, and welcome to Techsploration and Exploration in Technology. Today, I'll be going through some of the steps necessary to train your own Haar Cascades using OpenCV. You might wonder what each of these things are. Haar Cascades are used for image recognition. They use a series of shapes and boxes, and they match them up against an image to try and recognize edges where there might be, adjacent dark areas or contrasting light in dark areas to recognize edges. And you can, find tutorials on how to use these to recognize things like faces and eyes. But the thing is most of the tutorials, they all just require you to go and download somebody else's Haar Cascade. So I'm going to show you guys how you can set up your own Haar Cascade and choose what you would like to recognize rather than just whatever you can find on the internet. Alright, and so some of the technologies we're going to be using today is OpenCV, which is an open source image recognition software that supports using Haar Cascades as an algorithm for recognizing objects, and it also supports training those Haar Cascade files that are used. So what we're going to be doing today is we're going to be training our own Haar Cascade files, right? And then but before we are ready to get started, if you want to follow along with, I recommend getting your own Linux environment or ready, either installed or on a virtual machine, whatever you would like. Let's say install Python 3 and OpenCV installed as well. And you can find tutorials for this on multiple places on the web that will walk you through it much more thoroughly than I will be able to. So I will probably leave some links down below and let you guys get that taken care of on your own. Another thing is a list of images. So for this image recognition, we're going to be needing some images of both what we want to recognize and things that we don't want to recognize. So some negative training images, as well as, even if we just have one picture of the thing we want to recognize, that'll be enough. But we'll want to get as many as we can of negative ones. And I'll show you guys a way how you can take a list of URLs to images, and then we can go ahead and download them via a program and skip the process of painstakingly setting up everything and allow our computer to do some work for us and resize and convert the images to the grayscale format that we'll be using for the recognition process. Alright, next up I'll talk a little bit about what we're going to be using Python for in this tutorial, and that is to download those negative images from a list of URLs. Python is going to be taking a list of those URLs and it's going to be resizing them and converting them to grayscale. And so here's an example of just two URLs here, but then here's a list of a whole bunch of URLs of images. So I would recommend getting as many as you can, and there are websites that can generate these lists for you. So that's one thing that I would highly recommend doing, and I'll provide some links towards places which I have used to get some stock images for machine learning in the past. However, one of the problems with those stock image sites is sometimes if their servers are down, they will send you back a failed image, and you have to kind of remove those. So we'll talk about how we can systematically remove a lot of the ugly images we do not want in our training set. Then we're going to use Python to make a list of all of our negative images and convert our images to grayscale. So if we have our positive image as well as the negative ones we downloaded earlier. Alright, and then after we use Python for that, we're going to go ahead and move on to some bash scripting, doing a little stuff in the terminal here. We're going to use the terminal interface to the OpenCV library to first of all generate some positive training data. So from just one image, we were going to superimpose that image onto multiple different of the negative images that we downloaded earlier. or that we will download with the URLs provided from our list that we gather. So are going to superimpose our image of our object we want to recognize on top of all of the negatives and generate our own positive images from our negatives and just one source positive image. And then we're going to show how to organize that into a big training set that includes both a positive image vector file, which contains information about where the image is inside of a positive match. So our original image will have to be a little smaller than the ones we download online for negatives, and so that way when we superimpose it, it's within it and still is the same size as the larger. We'll also want to use our negative image BG text file we'll be generating with Python. That's this one up here where we make a list of all of the names, and that's just a name of all of the negative images for our training data. And then we're going to have our generated positives, which will be known about by this info file that's in a .lst, but it will have information about all of the positive images for the training. And then we also have to provide some other parameters for the size of our images and the count of how many positives and negatives and what levels of training we want to. And then we can go ahead and start up our training, and we will have to wait for a little while because machine learning can take some time for how many iterations we're going to do. But we'll go ahead and walk through some of that with you. Alright, so awesome that you now know what it is that we're doing, and that if you are choosing to follow along, that you have gone ahead and taken care of these preemptive steps and are ready to move on to use a little Python. So I'll jump over here. I've written up a little program which I'll provide a link to in the descriptions down below. But what it kind of does is it stores the raw images that it opens up from the URL list, and then it also finds and removes all of the uglies, which I'll kind of show you guys what that is talking about. And then we also create that negative description file, and then we're also going to create our grayscale seed picture. So I'll talk through kind of what is going on here. We have one kind of global variable, and this is going to be neg. This is our negative folder that all of our negative pictures are going to go into. And then coming into store the raw images, we're going to provide a file that is going to be the name of the file that holds the list of all of the URLs for our images. And then we'll also have this start, and this start is just going to be a number. So if we have multiple files and we want to do them in chunks, we could do one and get up to 100 pictures, and then pass in 100, and it'll start counting from there. So, but when we start off, we're gonna go ahead and start this one at 1. So this URL file. So first of all, right here, we're just gonna go ahead and create this folder if it doesn't exist. This is referring that we want to use the global one if the OS path exists, or if it does not exist, then we're going to make the directory. Alright, and then we're going to open the file that is provided, that is the list of the URLs, and for each URL in that list of files, we're going to call read lines on that open file. And for each URL, so this is a loop that's going to iterate through, and for all of them we're going to try, first of all, we're just going to print out the current number that we're counting on. And then for that URL, we're going to print out the URL so we see where we're going. We're going to use this URL lib request library. We're going to make a request, and we're going to retrieve that URL that we printed out, and we're going to store it in the negative library, and then this is just a little file path stuff right here, and then we're going to add on this number. So we're going to name the picture that we download by the number of the counter, and then .jpeg here. That's just proper file extension for the images we're going to be grabbing. And then we are going to use CV2 library, and we're going to read that image that we just created, or that file that we just downloaded above, and we're going to read it in as grayscale right here. We're going to resize that image right here with the CV library again, the image being the one that we just read in with grayscale, and we're going to resize that to be 100 by 100 pixels. And then this CV2 library, we're then going to rewrite back out to that same location, which is going to re-overwrite, the original download with the resized image here. And then we're just going to count up on the counter. And if something fails, we're going to print out and see, but it's alright. We'll have a couple failures of images that are in the wrong format, or sites that didn't actually give us a picture back when we went to download one. So that's kind of just a quick walkthrough of what the store raw images does. I'll go ahead and start running this as well in a Python interactive terminal, so you can see what's going on. Down here, you see I have just this print statement, but I have all these commented out so they won't actually activate. And this folder, or this file, is located in this code folder. And so I'll go ahead and pull over this file explorer over here and see this is the current path that we're working in right here. Now if we go ahead and run our store raw images, here I have these URL lists, and this one here, if we go ahead and just call store raw images, list.txt, and then we're going to start numbering at number 1. And we'll go ahead and run that, and sure enough it counted the number and printed off the URL, just like we were hoping it would right there and there. And so those are those two print statements going off for two URLs. There were the two in that list, one, and then this is a two-liner here, that wraps around. Alright, so let's see what we got now. Go ahead and exit out of the interpreter. And it went ahead and created that negative folder that wasn't there for us before. So let's look in there, and sure enough we have two gray pictures of barns, or sheds actually. But yeah, so this image recognition actually uses very low resolution images, and that way it's able to focus closer on the larger edges that appear without getting caught up in the detail. But let's go ahead and run this on a few more images. I have kind of pre-packaged in that second list that has, it's going to start us at 3 because we just had images 1 and 2, and then it is going to have about 50 images in here. So we're going to start working on that, and in the meantime I will pull this up and just kind of show you guys that as this goes through and updates, we'll slowly get more and more images appearing. And so these are being downloaded right now and put into here. And I'm going to start talking a little bit about what's coming up next, and that is the find uglies. See this right here, this is like a stock result that we get back, and this is not an image of anything that we want. It's an image that signifies a failure to get the image. So what I've done is I've moved a few different variations of uglies, and for some reason these are coming up as different, but every time I get one that doesn't get removed by the find uglies, I move a copy of it over here, and then it does get removed. And so I'll walk through kind of what that does over here. So in our folder of negatives, we're going to basically just go through all of the images in our uglies and compare them to the files in the negative, and if they are the same, we are going to get rid of them, and if they're not the same, then we are going to let them be. And if you guys are really kind of wondering how that gets done, it's this comparison down here, and it will say it's found and destroyed it. And with this new version of OpenCV, I think it's NumPy actually that's failing to get the shape call because it's not a proper image in the first place, and so it's going to complain a little bit more when I show you guys that in action. Looks like we're not quite done. Sometimes oh, it looks like we actually are done and have returned back now. So I will show you all of those negative images now that we have. It looks like we have a couple uglies that we'll want to get rid of. So to do that, we would just this is the function that we have up here. So if we just call find uglies, went ahead and ugly found and destroyed, ugly found and destroyed. Alright, and then if we go ahead and look, all of the uglies are missing from the negatives now. So we can go ahead and move forward and create the list of all of these images. So the way that we're going to do that is this create neg description function, and it just for each file in the negative directory, it opens the file, the bg.txt file, which goes off the name that's passed in as an argument. Opens that file as this f and just writes each line which it received from listing out all of the directories. And so each file will be appended into this text here by this write command. And so we can use that to generate our list of files if we just type in this and so for this I've got a little picture of the Chrome logo that I'm going to be using for my seed image, and so here's a picture of it. I copied it over 4 times because some people were curious about how you can do this with multiple different files instead of just the one. So I copied one over 4 times, but it's going to be the same thing as if you had trained with 4 different objects to get different angles that you were trying to recognize the same object from, like a front and a back, because things can look very different from the front or the back. So let's go ahead and train this with the Chrome logo. And what that did for us is it went ahead and generated this right here, which is a list of all of the JPEGs, neg15.jpg. And it looks kind of unreadable there, but I'll show you one more quick thing, and then I'll print out kind of what it looks like in here. So the next command we're going to be doing is this gray seeds, and what that does is it will open up this seeds, and for every picture in here, it will create a folder, one folder called gray, and then we'll create a copy of each of those seed images in the gray folder that has been converted to grayscale. So that way we can convert our positive image to a grayscale that we can use for the training. So let's go ahead and run that real quick. So we have this gray seeds function here. And sure enough, now we have gray, and we have our little gray chromes. So let's zoom in and show you guys. Little gray chrome image. Alright, so that's probably all the Python we're going to be needing for today. Like I said, I'll go ahead and get that posted so you guys can reference back on it without having to pause the video at a later point if you'd like. And now we're going to be moving on into a little bit of Bash. Alright, so I went ahead and created our gray images, our bg chrome logo.txt file, which is just our list of all of our images. We've also removed our uglies, and so next up we're going to be needing to generate our positive data. So the way that we're going to do that is we're going to use a bash script, and so I'll walk you guys through and talk you through what's going on, and then we'll go ahead and run it, and I'll show you a little bit what the output looks like. So first of all, this is just declaring a variable where every time this is used here in the $sign with the curly braces, it's going to insert this value. So it's kind of like a swap out, and this is more like a template file where you can kind of put your name in there, which is a few other minimal changes, and getting the environment set up be very close to going. So I went ahead and moved my gray images into this RPS folder and renamed them into Chrome logo rb.jpg, rf, lf, and rb for right back, right front, and left back, just to kind of give somebody else an idea who was asking me about this, how you would go about setting this up. And so this is where you would put in your different angles and aspect ratios and views. If you were trying to combine into one Haar Cascade the same object from different perspectives. So then what we're going to do is we're going to call this, first we're going to make a directory where we're going to hold all of the info that we're going to be generating here, all of the positive images. We're going to start off by calling the OpenCV create samples call, and just so you guys know, these four commands are all for doing generally the same thing, just with a different JPEG each time, and so and a different output, which we're then combining together the outputs from each of these commands down here all into the same command here, which we use on the next step. So this is just kind of how you combine up. Is you I'll walk through what this is you create samples, you provide the image that you would like to use for training, and then here's our bg .txt folder, this bg chrome logo text file that we created, the list of all of our negative images, and then here is a list of where we want our negative, where we want our positive list of images that we where we superimpose our image onto the other training data. So we'll go ahead and store them in these locations and then combine them up into one list. But this minus images our image info gives where we put that info for our positive info, and then we also provide a PNG output location, and it's that same directory, that info Chrome logo directory that it will be creating in this step, is where we want to put all those positive images. And then these next commands, this max angle, or max x angle, max y angle, max z angle, this is for degrees of freedom for it to rotate your image as it's superimposing it on the negative images. So you can, you'll allow a little skew and rotation, and so if your object isn't always upright or always seen from the same side, but moving a small angle doesn't change it drastically, then you can kind of just give it some degrees of rotation available here. And then you also declare the number of positive images that you want to create, and this will be based off of your negative images that you're able to collect. So earlier I collected a lot more than the about 30 or so that I showed you guys in this video, but I have a couple thousand that I'll be using for my training data. Alright, I'm going to go ahead and start running this while I keep talking about it, so you guys kind of get a chance to see without having to wait, hopefully. Alright, so right now it's going through and opening up all of these background images that it got from its BG text file, and we're going to do this 4 times. Then we're going to combine all of those outputs into one file here, which we were going to then take that one file and generate a positive vector file, which will be kind of the last piece, where it also includes the locations of the match in the file and the file directory. So next up is what's going to happen is that we're going to create a data output directory, and we're going to call our OpenCV train cascade. We're going to provide it a location where it's going to generate the output data to. This is where our Haar Cascade is going to show up. So this is kind of like our target build directory. We're then going to pass back in that vector file that we just created in the previous step, that we're currently waiting on to create over here. It looks like we've finished the steps up above here and are now working on the training down below. And so this training also takes the negative file, the negative image file. It also takes a parameter of how many negative images you would like to use. So right now in this training run I am using 9,000 positive images and 18,000 negative images. And the number of stages that I'm starting to train is 20 stages. And stages are basically every time you go through the training process, you then add more training data and retrain again until you can meet your thresholds of accepted quality of matching. And you continually go through this process of training to be good enough, and then getting more data, getting better, seeing more, getting better, seeing more. And so it's an incremental process that can help guide the training process by stepping in more data as it goes along, and that way it doesn't just stagnantly memorize how to recognize the initial data, but it grows with the data set. Just like you or I grow our knowledge base as we're exposed to more things. You know, you can think of it like that. But then this next, so it's going to go through 20, it will take probably a couple days to run 20 stages. But it'll output every time that it increments up to the next stage. So you can take the file and start working with it. You know, probably within the first hour or so, I'd say, you'll be able to have usable results. And then we define the size, so I'm using a 25 by 25 image here, so that's where we're training. And then this last little bit here is a pipe to direct the output to this T command, and the T command will output the results of this entire command both to the terminal as well as to this log file. And giving it this -a makes sure that it will append the to that log and not overwrite it. And so that's just kind of what's going on right now. We've finished our first step in our first stage of training for 9,000 and 1,800. I don't think I'll keep you guys here for all of this, but there is one more thing I wanted to kind of show you that's a little cool. So in these different feature classifiers that it's currently going through, and you know, building up a series of these that it can use to recognize your object. You wonder, you know, oh, well, how many different, you know, little classifier boxes can you have? Well, for a number of unique features for the given window size of 25 by 25 is 190,000 features. But let me also show you guys one last fun thing, and that is the training data that gets superimposed, where your image gets put on top of another, you know, negative training data. You can actually pull up those pictures and see what it is that they look like. And so we should have a info Chrome logo, and here it is. We've pasted our Chrome logo on a bunch of random pictures, including some I included some black backgrounds, so it just kind of has a good place to get started, as well as some different artifacts, and there's thousands of pictures in here. Of just different things. So you know, were to do this again, I'd say I should probably get a transparent background, and I think we would have to use a PNG, but that's no big deal. Yeah, so right now we're training this up, and oh, we get the scroll bar hard. Oh, it looks like we've finished stage 0, so let's see what we've got now. Let's see. So here's our stage 0. This this file right here is the one that we have our Haar Cascade, and so if you take that file that's generated and take it to one of these tutorials on the web where you can start doing OpenCV, pretty much drop this in here, but replace out, you know, the name of their Haar Cascades, you know, that one for the face and that one for the eyes, with, you know, 2 cascades that you made, and you'll be drawing boxes around them, and you can also you know, print words next to things, and so you're running multiple different recognizers. But yeah, so that's kind of a quick how to get started with doing some machine learning with OpenCV, Haar Cascades, Python, and the lovely Linux environment. Thanks for joining me, and have a great day.